Whew. Okay. She's usually not this active this time of day. All right, so I started recording. And last time we were talking about 2A, we introduced unit analysis. So it is, like I was saying, we simplify out units, one in the numerator, one in the denominator. That makes sort of like the big fancy sort of one, like we're used to with numbers. But now we have units to do it. Okay. And so the strategy is to set one thing in the numerator, one thing in the denominator. So this is a continuation on unit analysis. So I feel like a lot of the math in this section is very similar. If you got the unit analysis in the last section, it's the same sort of application here, but now they're giving us different, what do I want to say, different systems to work in. So we have the US customary system, we have the metric system. Those are the two major systems. We have conversion factors from those systems. So now we're doing unit analysis, but this chapter kind of just extends that unit analysis concept to like the different systems. And so what the heck was the question? I just clicked on this thing. 1 cubic foot holds 7.48 gallons of water, and 1 gallon of water weighs 8.33 pounds. So this is a two-parter, but how much does 6 cubic feet of water weigh in pounds? So I think this is a two-parter. Let's start with what you know. And give these an attempt. Try it. Try it out. If you don't understand it, I'm going to have a slide that like explains a little bit more. But probably not going to get it if you don't give it an attempt. Yeah. Cubic feet. I would start out with the 6 cubic feet. Is there some sort of conversion factor that has cubic feet that I can use to transfer that to a different unit? And how do I do that? So I think what I'm doing is I'm going from cubic feet to gallons, and then I have to go from gallons to pounds, is what it looks like I'm doing. So I don't know if I did this last time or said this or made it explicit, but like when I do these things, I don't even look at the number or like the conversion factor at first. I just think about the units. I think about how to get rid of those units. I got one on top, I got to put one on bottom. All right, now it's on top again. I got to put this one on bottom. And there are 8.33 pounds to every 1 gallon of water. And round it to 2 decimal places and put units on there. All right, I'll give you all a minute. Okay. Should try something out. Should have enough time to try something. And so a lot of these problems, and I don't think these are the ones that are like in the later problems, they ask some questions, and there's questions that you should really answer or respond to answer their question. And so there are some extra questions in here that are not in the book, but they're things that you should be answering anyway, if that makes sense. It's like there should be some middle questions. So this, we're doing pounds. I don't even think I needed that table for this one. I think I need it for the next one, probably. All right, so where are we at? 373.85. What else saying? I don't know where this is coming from. Should be multiplying those three numbers. And then the units it's going to give you is 373.85. We do it 2 decimal places. All right, so how do I get that? So like I was saying, I start out with 6 cubic feet. So come on, next bullet. To get rid of the cubic feet, the thing that has cubic feet in it is this. Where is it? There we go, that one. The 1 cubic foot holds 7.48 gallons. So 1 cubic foot to 7.48 gallons is my conversion factor. And so this, it's going to get rid of my cubic feet. So these should simplify these. And so now I am left with something that is in gallons here. So I want something with gallons on it. This tells me 1 gallon weighs 8.33 pounds. Whew, excuse me. So I know 1 to 8.33 gallons to pounds. I put my gallons down here because I have my gallons up here. So I put my gallons down here to simplify with those. So my cubic feet simplify. My gallons now simplify, and I'm left with something in pounds. And I think I have it. Next slide. Come on. 373.85. So we're multiplying these three numbers together. That's what this tells me, that they're all on top. I don't divide by anything. I divide by 1. Okay, maybe I divide by 1. It doesn't do anything when I divide by it. All right, so now we want to know in tons, 373.85. So if it helps you, I can put that up here. 373.85 pounds was what we found in the previous one. Now I'm going to give y'all like 30 seconds. 373.85 pounds is what we found from the previous problem. Now we want to convert that thing to tons. I think I need this right here. You might do this with the unit analysis. You may not do it with the unit analysis. You might kind of know what to do with those two numbers without doing unit analysis. This one is a one-stepper. Round it to 2 decimal places. Be sure to tell me what the units are. And I will give y'all, I don't know, 30 seconds. I mean, it should be a 50-50 shot, right? If you know, like 370, no, I'm blocking it. 373.85 pounds, and I know it's 1 ton to 2,000 pounds. You should have figured out you're either multiplying or dividing by that number, right? In order to convert it. You can maybe use a little bit of inference about what you know about pounds and tons to know whether it's correct, right? Without even knowing unit analysis, I feel like you should probably be able to like sort this one out a little bit. But with doing the unit analysis, you should definitely be able to do it. All right, I'll give y'all 10 more seconds. I think this is where I'm at. Oh, let me clear that. I'll end it. So you should have divided by 2000. We're going from what, small to big, divide the big to small, multiply all. Another one. Ooh. What are you telling me? 0.9, 0.19. Might have not counted it if you put 0.19 without the 0 in front. I don't know how. If you round it to 2 decimal places, it should round to 0.19. So it looks like some of you are getting the correct thing, just like a rounding issue, which is something the computer is going to count wrong, but like I'm not going to be too particular. Unless you're just rounding horribly, right? Unless you're just like rounding to whole numbers and it's just like you're thousands of dollars off in the end or something like that. Come on, next bullet. All right, so we started with 373.85 pounds. We know that 1 ton is 2,000 pounds. So maybe there's a question of how do I set this thing up? But if pounds are up here, guess where pounds got to go over here? They got to go on the bottom. So if we do this, and again, we have a pound on top, we have a pound on bottom. Guess what? We end up with something, come on now, in tons. So we're doing 373.85, and this is telling me when I multiply through and then divide, I have to divide 373.85 by 2,000 is what this tells me. Okay. Any questions over these first two? Okay. So this is something, you got to get this unit analysis stuff down. All right. All right, so this one's got a few details to it. Your utility company charges 13 cents per kilowatt hour of electricity. So right away, in my brain when I read this, I'm never gonna read stuff in cents. Like right away, I'm just going, that's 13. 13 cents is $0.13. Can I move this? There we go. So I hope right away you're like, no. Per kilowatt hour of electricity, what is the daily cost of keeping a 100-watt light bulb lit for 12 hours each day? How much will you save in a year if you replace the bulb with an LED that provides the same amount of light using only 25 watts of power? All right, so there's a lot here, but we want to start with talking about what is the daily cost of keeping a 100-watt light bulb lit for 12 hours each day. They are going to charge us per kilowatt hour. And if they're charging us per kilowatt hour, we probably need to find what electricity we're using in kilowatt hour. So the first question is, what is a kilowatt hyphen hour? What does that mean? And I feel like this is the thing that trips people up. What does the hyphen mean? If I say kilowatt hyphen hour, what is the operation there?
Multiplication.
It is we multiply it. Absolutely. Thank you. And so what we want to do is we have a 100-watt bulb. So the first thing we want to do is we want to convert this to kilowatts. So 100 watts, what is that going to be if I convert it to kilowatts?
Would it be 1/10 of a kilowatt?
Yeah, it's 1/10 of a kilowatt. So we got 1/10 of a kilowatt. We got to divide by 1,000 basically. Can I put this up in here somewhere? 0.1 kilowatt. So that's what I would do. That's a kilowatt. And we know we're going to keep it lit for what, 12 hours? each day. So if I want kilowatt hours, what do you think I have to do to these two numbers? And I think that's the thing that really trips people up. They're just like, you just said it. I got to multiply these things. So multiply these two things to get kilowatt hours. And then we know they charge this 13 cents per kilowatt hour. So take that into account. So I want you to give this an honest attempt. I do have this one broken down a little bit more on the next page. And so I feel like I'll give y'all a minute on this one. And so they say, well, what cost? Or what is the daily cost? So your unit should be in dollars. And you might have to round it. Someone was asking like what last class, and I should have looked it up to be honest. But like what the watts, what they mean as far as electricity wise. And I know like the way that they describe electricity is sort of like with a river, right? You have so much water in the river, and then you have the current of the river. So you have the wattage, I believe, and that's like the amount of water in the river. But there's also like the current of the thing, which you also have to know, which I believe is in amperes. Could be wrong, because I know you have to look at both voltage and amperes when you buy a device to make sure it will cover both of them. But there's like the actual amount of like electricity there, and then there's the amount that the electricity actually flows in the device. And there's two different metrics for those. But I believe the watts is kind of like how much water is there. And then when you multiply it by the hours, that actually gives you the flow there, I believe. That's why you have to account for the number of hours. But wait, no, we're multiplying it by time. So I believe this would be the flow. And then when we multiply the two, I believe that's the actual total amount of power that has flowed. That would make sense. Like I said, I definitely should have looked it up. I know it's a thing, and there are different metrics. Let's get warm up in here. Okay, so I think we should be wrapping up this problem. I need to clear my annotations. So it should be 16 cents. Where are we again? 15.616. Yeah, I didn't do it in cents. So if you're doing it in cents, I don't know what to save. That's the next question. All right, so what's the daily cost of a 100-watt bulb? So some of this I talked a little bit about, but the first thing we want to do is convert the watts to kilowatts because our charge is in kilowatt hours. So we want to convert this to kilowatts. We have hours here. So 0.1 kilowatt times 12 hours would give us the 1.2 kilowatts hours that we're using. If we do 1.2 kilowatt hours, and we know it is 0.13, the equation editor does not let me use the dollar sign for some reason. So that's why I have the word dollars written out every time you see I do it with the equation here. But this should give me something in dollars. I know I'm charged, this is like the apples problem if I'm getting 10 apples for 9 cents or something like that. I know I'm multiplying those two numbers. And if I multiply those two numbers, it should give me 0.156 is what you are getting, or 15.6 cents was also correct. It's just not the units I put it in. So I would give you that, but typically I'm going to stick to dollars when I talk about prices. And in general, I feel like that's probably what you should do anyway. Someone's asking you the price, unless they're being weirdos or they're talking about the price of gas. We don't usually use like, you know, those thousandths of a cent or whatever. Thousandths of a dollar. I guess it's not a cent. Cents is 100. How much will you save in a year if you replace the bulb with a 25-watt bulb? So we had that thing a while ago. Let's look at the full question. So first thing I want to do is convert 25 watts. So how do I convert 25 watts to kilowatts?
You move the decimal place.
Yeah. So how many decimal places? What does it look like?
3.
Yeah. So there should be a 0 there, right? That's what I was trying to get at. A lot of people will miss the 0. But you got to move it 3 decimal places. So you got to add a 0 there. 0.025 kilowatts. So we multiplied what? Watts by hours by the rate is what we did last time. So do the same thing. Watts times the number of hours times the rate. That's going to get you the daily cost of the 25-watt bulb. Then you're going to have to find a way to make those annual costs. You're going to have to take the difference between what we found last time, which was what? 0.156. So daily cost of what? Daily cost of 100 watt was 0.156. This is what we found out previously. So we want to find the cost of this bulb now. We do kilowatts by hours by the cost to find the cost. That's the way we did the last one. Now the only thing that's changing is this power. We're still having it on 12 hours a day. They're still going to charge us the same amount. After we find this cost, they want to know how much it's going to save. So they want to know basically what the difference between these two things, right? That'll give you the daily difference. Then we got to convert that to yearly. So if you're going to save that much each day, how much will you save throughout the year? Or you could find the yearly cost and yearly cost here and take the difference. There's actually 2 different ways to do this. I can think off the top of my head, at least 2 different ways. So either take the difference and take the daily difference and find the yearly, or take the yearly cost and then find the difference. So give it a whack. Try to do something. Probably give you a minute or two on this one. It's definitely got a few steps involved here. Don't forget your $sign when you're done with everything. All right, so hopefully wrapping this one up pretty quick. Okay. So we talked about how to find cost of the last one. So the find the cost of this one should be very similar. You find the cost, it should be what, like 30? No, it's not even 30 cents. It's 3 cents and like 9/10 of a cent or something like that.
I was freaking right. And they told me I was wrong.
It should be 0.039 is the cost, but then we have to subtract those two things, right?
No, I was right. And I just didn't put a 1 in, and they're like,
What'd you do? 42.70?
yeah.
Oh, that's close enough. I know it's not going to count it right on the computer, but yeah, it's close enough. You got it. You got the hard concept. Like, don't freak out on yourself on that.
My brain was like, error.
42.71. 142 is a little high. 42.71. I'm seeing some 42.71s. 39 cents is the cost, but we still have to subtract it from the other one, and then we have to multiply by 365 to get to the yearly cost. So a little bit of breakdown here. This was from the previous problem. 100 watts cost you that much per day. The 25 watts, if we want to figure it out, I believe it's like almost 4 cents a day. I think some people rounded it last time and they got 16 minus 4. I think that even gives you the same solution, but I could be wrong. It might give you a cent off. If I'm pretty sure I've said it a few times, but like if you're a few cents or something off, I'd like, as long as you're getting the process right? This is all the hard stuff. If you're getting this stuff right and you're like a few cents off, I don't care. Like, you're honestly doing the hard stuff. Like, but don't go rounding stuff willy-nilly either. You get far off. If you're telling me $45 here, then that's off. You know, that's a little far. So it cost the savings when we subtract the two. It cost like 11, almost 12 cents more per day. And so if we do 12 cents per day times 365 days, that's going to give us the 4271. The other way you can do it is you can multiply each of these by 365 and then subtract them. So you can either subtract and multiply, or you can multiply and subtract. And that has to do with like that distributive property. That's where that's tying in. Questions about this? There's a few people getting it. There's a few people off. Like a mixed bag.
My big problem is just that I have so much trouble remembering the steps. That's just my biggest problem.
Okay, so when we measure material density, and this is just something I put on here as a sort of a hint, material density of water is 1 gram per cubic centimeter. So this is telling me what units my material density is in, because if I'm being honest, I wouldn't know it off the top of my head. But when I read it, it makes sense, right? Grams is giving me the mass. That's telling me how much material is in how much volume. That's telling me density. So if I want to know what the density of this block of oak is that has a volume of 200 cubic centimeters and it weighs 0.12 kilograms. I want to put this in grams per centimeters cube is what I want to do. And so the first thing is, what is its density? That's the first question, which is this one. So I want to put this in grams per cubic centimeter. We can make that conversion. I feel like this one, I don't want to say it's easy, but
I divided it, the kilogram divided by the cubic centimeters of 200.
We got to do this thing first. What should this be in?
Oh,
I got to make a little conversion to this thing first. So this is in kilograms, and we want to go to grams per centimeter cube. What do we have to convert this thing to? Is that making sense? Or am I speaking gibberish? Oh, where's my little hat symbol? So your unit should be what? In grams per cubic centimeter. Let's make sure. I could have swore my phone had that little hat symbol, and now ever since I started this lesson, I can't find it. I don't know if it's hiding somewhere on there. Okay, so I feel like 30 more seconds. Like, we just got to convert this thing, right? No, just the first one. What is the density? So what is the density of this block? The next one will be is it a floater or a sinker? So we want to put this, they're giving us kilograms, they're giving us cubic centimeters. We want to put this in grams per cubic centimeter. So we are going to divide this by this, but we got to convert this before we do that division. And so we're converting.
Wait, so how do we know if it'll float or not?
That'll be the next question. And so I will talk about that in just a second. I didn't mean to like put you off too much, but it'll be easier to answer that question after we have this question answered. I feel like if I can reference this solution, then it might be a little easier to explain. All right, should be wrapping this thing up. So we convert kilograms to grams, big to small, should be multiplying all by 1,000, dividing it by 200. So I believe it should be like what, 120 over 200. And if anything else, it's probably those units that are going to get you on this computer thing. I don't know. Grams.
Dang it, I typed in the units wrong.
If you got 0.6, that's good enough. Who did the little hat? Where's your hat at? Are you using a cell phone? Abigail? One of you? I can't find it on my phone keyboard for some reason. 0.6, if you got 0.6, I'm pretty happy. You're getting this stuff. You're getting the concept, right? We convert that thing to grams, it's 120 grams, we multiply by 1,000. We do the grams over cubic centimeter, 0.6. So the density of this thing is 0.6 grams per cubic centimeter. The density of water is 1 gram per cubic centimeter. So is it more dense or less dense than water? And if something is more dense than water, is it going to sink? Is it going to float? What does that mean? So this is a 50-50. So hurry up, click something. But it is 0.6 versus 1 is what we're comparing. So if this is 0.6, what does that mean? Is it more dense or less dense? It should mean it's less dense, right? And if something is less dense, is it going to sink or float? It's going to float, right? There is less material per volume there, which means it is more buoyant, it is less dense, it will float. If it was larger than 1, right? Ooh, most people got that. That's pretty good. If it is more than 1, then it will definitely sink. So these next questions, they're pretty involved, and I just kind of like, I feel like it's a good strategy to read what you have to do before you do it, right? Sometimes kind of get an overall of like where we're going to lead with the question before we actually start dunking our head in the water. Pun fully intended, I guess, on this one. Shower versus bath. We are going to compare how much water you use in a shower versus how much water you use in a bath. So you fill the tub to a halfway point, and the tub measures 6 feet by 3 feet by 2.5 feet. So they're giving us a tub dimensions. They're telling us we're going to fill it halfway. When we take a shower, your shower head has a flow rate of 1.75 gallons per minute, and you typically spend 10 minutes in the shower. There are 7.5 gallons in 1 cubic foot. So I know like that is a lot of information just to throw out at you. It's a lot of rates and different stuff, but like from like what you just read, I hope you gather, they're giving you probably enough information to figure out how much water are you using in a shower, how much water are you using in a bath. Do you use more water taking a shower or taking a bath is going to be the first question. In order to figure that out, you got to know how much water you're using in both of those. So that's going to be the question I ask y'all. How long would you need to shower in order to use as much water as you use taking a bath? Assuming your shower is a bathtub, propose a non-mathematical way to compare in one experiment the amounts of water you are taking a shower and a bath. I like that one. I don't like the fact that they say non-mathematical because it is mathematical. It is just not formal math. You're still thinking like a mathematician. All right, so shower versus bath. Do you use more water taking a shower or a bath? So the first thing we need to figure out is, well, how much water are we using? So how much water in gallons does a bath use? So let me come back up here, read this thing. Let's try to determine where they're talking about baths, where they're talking about showers. I believe the bath stuff is right up in here. When you take a shower, like I think I can just probably ignore like all this. This is all stuff about showering. I don't want to take a shower. I want to see how much dirt is there after I get done. This is gnarly, man. That's what I think. Like the old timers when they like you never took a bath. It's just like go into the hotel, take a bath. There are 7.5 gallons in 1 cubic foot. I think I actually need this one. So this is giving me a conversion from cubic feet, an area measurement, a volume, sorry, a volume measurement, 2 gallons. And then they have the tub. So the tub I know is 6 feet by 3 feet by 2.5 feet. And the other thing I have to account for is that this thing is halfway. So I'll give you a hint. I think the approach we want to take, and it's probably jumping out to some of you mine, maybe not. But this is what, 6 feet by 3 feet by 2.5 feet. I think we want to take the volume of the tub and probably half it, and then probably use this thing to convert volume to gallons. Okay. And so you should get a number, you should get a unit, which is gallons. So that word gallon should be in your response, hopefully, right? Chair squeaked and sound like someone saying what? But, nope, just hearing things. All right, so I will give y'all a minute. Oh no, I'm not. If I go up, it's gonna be really messed up. 5 y'all, okay. This is the harder one. The shower, I feel like, is a little bit easier, but maybe not. We're at 2 people got it submitted. That's about how many people have been active today. That's about how many people were watching the videos. So, you know, it's kind of going hand in hand. If you watch the videos, you probably get a little more out of the class. Okay. So I believe we multiply these 3 to get what? The volume. We divide by 2 because we're only doing half. And then there are 7.5 gallons for every 1 cubic foot. So I believe we're multiplying by that last number as well. Okay, let's see where we're at. Well, 68.75. 330. Oh man, I know what you did. You didn't divide by 2. We got half a tub. So if you did 337, I believe you didn't divide by 2. 4.35. I'm not sure. 22.5. I think maybe you're dividing by that last number when you should have multiplied if you're getting that other thing. I could be wrong, but I think that's what you did. But here we go. If we want half a tub, it is the 6 by the 3 by the 2.5 is giving me the dimensions of the tub. I only want half of it, so that's where this dividing by 2 is coming from. So if I have 22.5 cubic feet, and I know there are 7.5 gallons per cubic feet, if I want to get to gallons, I'm multiplying these two numbers. So I didn't do it here. This is like one of the first times I hadn't done it in the notes, right? But if I really wanted to, I could put this over 1. This isn't my numerator. This is going to give me something in gallons when I multiply. I should be getting 168.75 gallons. Any questions about this one? How to get this one? Why we're doing anything? How's it doing? All right, so the next thing is the shower. How do we figure out the gallons that are in the shower? And I believe there's just 2 numbers. Full question view is where I want to go. I believe there's just like this one is a little bit simpler, I believe. The shower, it says it right here. All this is the bath stuff. So the shower starts right here. Use the shower head, and it gives us this number has to do with the shower. And this number, 10 minutes, has to do with the shower. So if we are spending 10 minutes in a shower that uses 1.75 gallons per minute, how many gallons are we using? This is like a rate sort of thing, right? If we're driving 60 miles an hour for 2 hours, how far have you driven? Same sort of thing. If we're using this many per minute and we're going this many minutes, how do we get gallons out of these two things? So you should have a number, you should have the word gallons. And I feel like this is one that should take you maybe like 30 seconds or something. Multiply by, got the wrong number. It's all right, do it again. You'll have time. You can redo it right quick. I know you can't resubmit it, but you can redo it. See if you still get the right number. Make sure you're still on track. All right, so this is 10 minutes. This is 1.75 gallons per minute. So if we want to figure out the number of gallons it's being used, distance equals rate times time. Distance here not really being distance, being the amount of water used, I guess is what it'd be, right? Let's see. Oh, here we go. I think most people are getting it. The other one, one of you already said you multiplied by the wrong number. Ooh, I think most people are getting it. All right, 115. I'm not sure where that's coming from. Oh man. Okay, so remember those amounts we just figured out? It was like 100 and something versus 10, right? I think something. But which one uses more water? So now this is the question that they asked in the book. So we're talking, what was it? 168 versus like 17 gallons or something like that. 168 for the bath, 17 for the shower.
168.75 for the bath, 17.5 for the shower.
Yeah. So which one of those uses more? This should take you 10 seconds after you just heard those numbers. All right. I hope this looks like a big, big tower. and maybe a little molehill over here for one person that was just falling asleep. But I hope this looks like a big, big tower on the bath. Hope you realize 168 is way more than 17. You're going to use more water taking a bath than a shower. But they're also taking a 10-minute shower, but even still, right? You'd have to go how many minutes? I think that's the next question, right? How many minutes would you have to go in a shower to make it match the bath? So that was 168.75. Is that what you said? Did I say that right? Bath was 168.75 gallons. Is that right? I believe.
Yes, it is.
All right. And now, how long would it take? How long would you need to shower in order? Oh, I have it written right here. Sorry, 168.75 gallons. How much water? How long would you need a shower in order to use as much water as a bath? So, key things that were taken away. We want to know the shower. What's the rate of the shower? I believe my rate of my shower is this thing. Oh, don't draw a text. Draw a drawing. There we go. Why don't you know my name is Simon, and I like to do drawings. 1.75 gallons per minute. So if I'm using water at a rate of 1.75 gallons per minute taking a shower, how long is it going to take to use 168.75 gallons? If you do your unit analysis, you should end up with something in minutes. Oh man, yeah, I think I fixed that one. Okay. It's not this one anyway. So round to 2 decimal places. I think you might have to round up on this one. We're at 6 people. I like I like part C. It's kind of silly, but it's kind of funny. All right, so if we start out with 168.75 gallons, and we know it's doing this many gallons per minute, it might be a little weird, but this is giving us a fraction with gallons on one end and minutes on the other. So I believe gallons should be in your denominator, right? And minutes should be in your numerator. Gallons on bottom, minutes on top. And if we do that, what that's telling us is we're going to take 168.75. And it should be division with this thing, I believe, right? And if you do that, it should be giving you, or is it 96, something like that? 96.43. In 22 minutes, 96.43. What are y'all doing? That's an hour and 36 minutes, isn't it? 96.43. 96.4 is good. An hour and 36 minutes is good. I didn't put it in that way, but that's the correct response. That's good. It looks like you're off by like a decimal place here for some reason, and I'm trying to think of what we do. I'm not seeing it. I think maybe you shifted a decimal somehow. Or maybe you put in the 10 minutes. I think maybe you did something with the 10. That would also throw it off. Okay. I guess I could put it up right quick in annotation. It said what, 1.75 gallons for every what, 1 minute? And so if we were looking at this, what we're supposed to do is divide those two things. You divide those two, you should be getting something in minutes. It should give you that 96.43. So you'd have to take a shower for an hour and a half, is what they're saying, in order to use as much water as a bath. In part C, if we want to propose some sort of experiment, you want to see if taking a shower versus taking a bath, which one uses more water. What's a really easy way to do that? This is so silly. Without doing any kind of equations, like what are you going to do? I have no idea what the numbers are. Put a plug in the drain. That's exactly what you could do. Yeah, it's a silly question. I'm going to go ahead and go on with this. That's enough time on this one. You put a plug in the drain and you continue taking a shower. See if it fills up as much as it does if you take a bath. Sometimes I do that when you plug your drain. You can compare the two amounts. It's a geometric proof. It does not. It's not necessarily non-mathematical. I think that's a silly word. Everything is mathematical. You just got to know how to look at it. When the metric system was first proposed, the unit of area was the R. So now we're going to sound like a pirate on this one, probably. 1 R is 100 meters squared. Today, the accepted metric unit is the hectare. Ha, where 1 ha is equal to 100 R. This unit is used around the world in forestry and agriculture. So this is, I believe, European. They use the hectare, and we'll talk about it in a second. But over here, we typically use acres. So using a power of 10, okay, this confused people. Don't let that confuse you. What they're asking in the first one is how many square meters are there in 1 hectare? Express 1 kilometer squared in hectares. Find the conversion factor between hectares and acres. So this is something you're going to have to use your computer to do. I use Google. You don't have to do it. I did it for you. You're welcome. Anyway, use the currency conversion in table 2.1. So using currency conversions, we're going to look at these prices and comparing them. So just like we did with gas prices in the previous one, we're going to look at land prices. So 5,000 an acre would be like a price over in the US. 10,000 euros per hectare would be like a price over in Europe. How do those compare? Well, in order to compare them, you probably know this, but we got to put them in the same units, right? Same metric. So I believe what I did is I converted this one to dollars per acre. Just so I know, because I know what dollars per acre means. I can't believe we haven't switched the metric yet. It's 100% because of that thing I just said, that attitude. It's just like, I know what this means. But if they switched it, I would know what the other one means. I only know what U.S. customary means, and it only makes sense because it's what I grew up with. It does not make sense any other way. Like, look at those numbers. Like, this is like the most, they just give you a headache looking at them. Metric is so pretty, so clean. We just multiply by 10, we move a decimal place. Big blue. When the metric system was first proposed, the unit of metric. So this first question is using powers of 10. That's because we're in metrics. How many square meters are there in 1 hectare? So I believe we need to take this. They want to know how many square meters there are in 1 hectare. So I believe we're starting with 1 hectare. And we want to end with a measurement that is in square meters. So we start with 1 hectare. I think we're going to have to use this thing. And I think we're going to have to use this thing. And we're going to have to set them up so that we get rid of hectares. And we get to square meters. And remember, if you go into the thousandths place, remember your commas, remember your decimals, those sorts of things. R 100 meters squared. Okay. I know a few people did this, they were off by like a 0 or something. Oh, I forgot my units. Darn it. Whoops. So this is a two-step. I'll give you all that much. We start with 1 hectare. This is the only conversion we have that has 1 hectare. So we're gonna have to go from hectares to Rs, and then from Rs to square meters. I should have added a response to this because I think I know what they're asking. But it's an even question though. Yeah, that's right. That's why I don't know. The evens, they don't have the solutions to. I didn't use a power of 10 in my response. And I think that's what they wanted us to do. I don't like, this book isn't always like super clear on the way that they phrase things, I feel like. So if sometimes you feel like the book isn't phrasing things clearly, I'm right there with you on it. Sometimes it takes me a minute to read what they're saying and try to understand what they're saying. Oh man, I forget my Steam comes up. All right, I'll give it a few more seconds. And I know I already got it wrong because I didn't put my units on it. We're gonna hear a womp womp. Ready for the womp womp? Okay. Womp 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 womp. Womp womp. I feel like their sad sound is too happy and their happy sound is a little too sad sometimes. 10 to the 4th, that is absolutely right. And I think that's what the book actually wants on this one. So if you said 10 to the 4th or you said 10,000 meters squared, that is beautiful. 10,000, that's what I said, but I didn't put that. It should be meters squared, not cubed. But there we go. That is the right number. You did the steps and the processes is correct. You just didn't put a comma in there, but it should be 10,000. Both those 100s should have ended up on top. Did I break this down? I think I did break it down. There we go. But we start off with 1 hectare, and then the conversion factor we have is 1 hectare to 100R, 1R to 100 square meters. So I set this up so that my hectares are the first thing that cancel. I set my hectares opposite. I set my R's opposite. R. Here we go. 10,000 square meters is what you get when you do 100 times 100. There are 1, 2, 3, 4 zeros is what you got to count your zeros basically, right? Okay. Lowered expectations. Burp. Oh man, that's probably something that's dated. Yeah. There used to be a skit on Mad TV called Lowered Expectations. They'd have different characters on there. It's like a little dating videos. They used to be a thing. People used to do videos to go on dates. Express 1 kilometer squared Oh, I like this one because it brings it back. Okay. Express 1 kilometer squared in hectares. My advice, we got to be really careful with this thing. 1 kilometer squared is 1 kilometer. Write it out what it means. It means 1 kilometer times 1 kilometer. How do I convert that? This is not kilometers, this is meters. So I'll give you a hint. We got to go from kilometers squared to meter squared. This will get us from meter squared to hectares. So you have to be careful with the dimension analysis on this thing. So this is like a 2 or 3 stepper. It's got a few steps to it. The Texas 2-step, which is a 3-step elsewhere because everything's bigger in Texas. So 2 steps is 3 steps. That's how it works. I'll be quiet now.
Our COVID cases are going to be bigger in Texas too.
They are. It's horrible what's happening.
I saw a post that's like Texas wasn't the only state. There's like Idaho and stuff.
Yeah, I mean, like, well, like I have some friends that like live in Georgia, and Georgia did it, like, and then their cases spiked. It's like, it ain't rocket science, right? Like, if you do this stuff, like, it's gonna spike. We understand it. It's just like they would rather have production than have living people. I think is what the honest truth is of the matter. I think the honest truth of the matter is that we are sacrificable to a lot of people. Okay, let's do this. You got to convert 1 kilometer squared to square meters. And square meters we can convert to hectares. Ha. Oh man. Okay. So I feel like the thing that's hard on this one is that dimension analysis. It's a little weird. But we know there are 1,000 meters for every 1 kilometer. Make sure you put those things correctly. And remember, there's 2 kilometers there. They are squared. This thing, are y'all working on this? Is it loading people? It like lagged last time. Getting kind of, yeah, see, a few more people answered. Sometimes it lags. All right, I'll give you a few more seconds on this. All right, so hopefully you're finishing this one up. That one always confuses me. It sounds like it's wrong, but I think it's a correct response. Did I not say that? What did I say? It should be 100. 10,000. I think you multiplied by the 100 instead of dividing by the 100 there or something. 0.01, you missed one of the dimension analysis. Didn't divide by the 100 to get to the hectare, I think. You missed the dimension analysis. So this is the thing that I'm talking about. I got it broken down on the slide. So if you got the 0.1 or 0.0, yeah, it should have been 0.1, you missed one of those dimensions. And so this was the thing I was talking about. This is the thing that I feel like is the tricky part of this question, right? Is 1 kilometer squared means 1 kilometer times 1 kilometer. We have to do this conversion twice. So this gets rid of one of the kilometers, 1 kilometer to 1,000 meters, but we got to do that twice to get to square meters. So now we are in square meters. And so now that we're in square meters, I believe we have that conversion factor from the square meters to, excuse me, to the hectares, right? There are 10,000 square meters to every 1 hectare. And I didn't do it here, but there is a really simple way, right? And this is what I do in my head. Like I go, this is 10 to the 6th up here. Down here, this is 10 to the what, 4th? And I believe I talked about this in the notes. But if I want to talk about these two things being divided, I can subtract their exponents. So if I think about 10 to the 6th over 10 to the 4th, it's going to give me 10 squared, or it's going to give me 100. Questions about this? So there should be 100 hectares where I would be. And if you want to do your slashing, you can do your slashing here. But that gets rid of those kilometers. This is my meter squared over here, and I'm getting 2 hectares. Questions about this?
Why are we multiplying the 1,000 by each other?
Okay, so this is the dimension analysis, right? So if it was 1 kilometer has 1,000 meters, right? But if we're talking about square kilometers, if I did it just once, so pretend like this one isn't here, right? If I did it just once, I would only be getting rid of one of those kilometers. I need to get rid of both of these kilometers. And so this is coming from the fact that basically that this is a square unit of measurement. We have to do our conversion factors twice, right? It was like if I triple one side, I'm doing it by 9 times, right? 3 squared is 9. If I triple one side, the single dimension is by 3, but the square dimension is by 9. The 3 dimensions is by 27. This was going back to that thing that we started talking about in the geometry section, but it's also coming back here. And if we do dimension analysis, right, we can kind of see why we have to do it twice, because this will get rid of one of the kilometers, but we still have another kilometer here we have to get rid of. So it's coming from the fact that there are 2 sets of kilometers when we talk about kilometers squared.
Okay, cool, thank you.
It's the dimension analysis thing. So this is a C. 1 hectare is at 2.47015. I got that from Google. So that's what they wanted you to do for part C. I don't know how else you're going to do it. Going to go probably do a decimal system in the library or something. I don't know. But Google's probably the quickest way. So we want to compare these 2 prices. So we got to convert one or the other. So I chose kind of for you, I guess, convert this 10,000 euros per hectares to dollars per acre. So there are two things I want to convert. I want to convert euros and I want to convert hectares. So if I'm looking here, my euros, and I talked about this table last time, but this is dollars per foreign. So this would be like dollars for every €1. And I can flip this fraction if I want, right? This means I have a fraction. I can put the dollars on top. I can put the dollars on the bottom. Doesn't really matter. I know I'm writing out the fraction this way. And this is the other way around. So this should say euros per dollar. So I know I'm writing it on here, but you should really know, you should kind of know this by now, or should be able to like read this table and kind of decipher from the table, hopefully. So I want to convert euros to dollars using one of these numbers. And then the other thing I want to do is, let's get out of here. I want to convert what? Hectares to acres using this conversion factor. So I start with 10,000 euros per hectare. So the number in the table should get rid of your euros. This number should get rid of your hectares. So set it up so that we can get rid of it. And I have this in the nearest dollar per acre is what I have it in. So I didn't round this to 2 decimal places. I rounded this to the nearest dollar just because it's a large enough number. And the units on it is dollars per acre. Okay, so I think you should probably either be like what, multiplying by the 1.058, or if you do the other way, I think you're dividing by this one, the 0.9449. So that's going to get us to dollars per hectare. And then if we want to get to acres, our hectares are on the bottom. Wait, no, our hectares are on the top. Our hectares are on the bottom in our units, so they need to be on the top here, which puts this number on the bottom, is what I was trying to say. So we should be dividing by this number. So you're either multiplying or you're dividing by this one. And then the second step should be to what? Divide by this one. Is that what you are doing? I guess we'll see. I don't know. What are y'all telling me? 42, 10,000? No, it should be 42, somewhere in the 42, 82. Yeah. 4,000 should be in the 4,000 range. So which is more expensive? I'll give y'all 10 seconds on this one. Is 4282 or is 5,000 more expensive? Hey, you guys, what? 5,000 is more than 4,000. So this is one of those lessons learned thing, right? Hopefully. You need to convert units before you start comparing things, right? I think is what the point is, what they're making here. Okay, so this is a sunlight problem, and what we're really supposed to do is answer 88. But in order to answer 88, we have to answer like this part in 87 about how many watts this thing is producing. So use this following facts: a solar panel, if it's 100% efficient. So if we get 100% efficiency, we get 1,000 watts, is what this thing is telling me. And that's if it's exposed to direct sunlight like all day, we're going to get 1,000 watts out of it. So for 10% efficiency, we're going to get 10% of 1,000 watts, which would be the 100 watts. And so for this first one, 87, if we want to know how much this cell is going to produce. So they give us this 1 square meter panel solar cell, and it has an efficiency of 20%, and it's 6 hours of sunlight each day. So there are basically two things we have to do to this. If we get the full power is 1,000 watts. So we have to take 20% of this, and then 6 hours is a quarter of the day. We take 20% of this, and we take a quarter of that. So this one, I'm hoping it takes you a few seconds, but I want to take 20% of this, and then I want to quarter it. So if I take 20%, I'm doing what? Multiplying by 0.2. Okay, so I multiply by 0.2, I divide by 4. That's what I'm telling you. It shouldn't take you that long to do that. That's two operations. Oh man, I wasn't trying to spend all day on that one. Okay, so we want to supply 1 kilowatt of power to a house, the average household powered by putting solar panels on its roof. Okay, so basically what this is saying is we have the solar cell from the previous problem, which can supply 50 watts for every 1 square meter. And then we want to know if we need a kilowatt, which is the average power that a house uses, how many square meters would we need? So we're going from kilowatts, and I believe we have to use the middle guy of watts, because this is going to go from watts to square meters. So how many square meters would you need of solar cells if you wanted to supply a house, is what this is asking.
What was the answer for 87?
87 was the 50 watts. So if we do 20% of 1,000, it would be 200, and then we divide that by 4. It's giving us 50 watts of energy is what this thing is going to give us.
Okay, thank you.
And so for each 1 square meter, we're going to get 50 watts of energy. And so if we need a kilowatt or 1,000 watts, right? How many square meters would we need? All right, so there's basically 2 numbers I think you should be using, right? 1 square meter to 50 watts is the conversion. The other thing is what? 1,000 watts. So if we start with 1,000 watts, how is this conversion looking? So I believe the 1 square meter is on top, the 50 watts is on bottom. So I think what we should be doing is taking 1,000, dividing by the 50 watts per square meter. Are we still here? Do we still want to go over homework?
We're still here. I think we're all just
Okay.
having a little trouble with these last ones, maybe.
Okay. Okay, so you want to do 1,000 watts, and then we have 1 square meter on top, 50 watts on bottom, right? So it should be 1,000 divided by 50. Should be giving you 20 square meters. I think we got just 1 more, 2 more. Is it 89 and 98? I can't remember. Okay, so when I talk about wind turbine, using electricity to generate wind, a typical installation, a single modern turbine can produce 2.5 megawatts. How much energy in kilowatts hour can such a turbine generate in a year? Okay, so it's telling us it can produce this many megawatts. And it's got more questions, given that the average household can do this. Okay, that's how many houses can we supply? That'll be the next question. This one is, how much energy in kilowatts can a turbine generate in a year? And so if they give us 2.5 megawatts, what do we want to do with this megawatts?
Multiply it?
We're trying to get to what unit? It might be multiplication. I'm looking for maybe a dumber answer. I don't know, maybe. What do we want to do to this megawatts? We want to convert it to turn to kilowatts is what someone said in the chat. Yeah, we want to convert this megawatts to kilowatts, and we know it's producing this, and we want to figure out a year. So the next thing is we have to convert a year into what? This might be the weird thing.
I think this might be the hardest question.
Yeah, I mean, it is a bit weird, but it's there. We want to get to kilowatt hours, and they're giving us a year. So this is time. A year is a time measurement. So what time measurement do we want to break a year into?
Days.
Not days. We're making this to kilowatts. We got to make this into
Hours.
hours, exactly. So we're converting this to kilowatts. We're converting this to hours, and then we're multiplying the two. All right, so let's do that. I don't want to spend a whole lot of time doing this, but that is our approach. So how do we do that? I think it's the next page. Okay. Come on. Next slide. Come on. All right, megawatts is 10 to the 6 watts. Kilowatts is 10 to the third. So if we do 2.5 megawatts, it's 10 to the 6 over 10 to the third. And this is the same thing. It's like subtraction. So I believe I have like 10 to the third on top. I would have to move this 3 decimal places if I really wanted to figure it out. But this is getting me from megawatts to watts, and then I use watts kind of as a middle guy. There's a few different ways to convert things. You might see another way, but basically we're going to move this 3 decimal places over to get to kilowatts, is what this is telling me. The other thing is 1 year to hours. So we got to go 1 year is 365 days. 1 day is 24 hours. If we do this, we end up in hours. So I have this thing that's in kilowatts. I have this thing that's in hours. I think everything is getting multiplied. I don't see anything on the bottom besides from this. Ooh, excuse you. But this I can simplify a little bit. Like I said, I can take out here and maybe do this as what, 10 to the third instead. But I multiply everything together, the number that I should be getting. Come on, bullet. When I multiply this top one, which is 2,500, by this bottom one, which is 8,760, I'm getting this ridiculously large 21,900,000 kilowatt hours. So this is how much energy a wind turbine is generating in a year. They want to know how many households, if each household uses, what was it, 1,000 kilowatts is the next question. So we got 21,900,000. Let me clear these annotations. And now we know this, that each household is using 10,000 kilowatt hours. So how many households can we supply is the question. And it was 21,900,000 kilowatt hours is what the wind turbine was generating from the previous one. So if each house requires 10,000 kilowatt hours, how many houses will this supply? This one looks awfully like the DVD cases. So you should give me the number. You should also tell me it's households, I think is the unit on this, right? So we're dividing this power into these houses is what we are doing. So I believe we're taking what, 4 zeros away from this thing? If we do division between these things, we're dividing this power into houses that hold this many kilowatts. Sort of like what we're doing with the DVDs. So 21,900,000 divided by 10,000 ought to give you what, 2190 households, I believe. Are y'all getting this? People that are still here, at least. What are y'all saying? What are y'all telling me? What are y'all doing? 2190. I don't. Why is it not kind of?
The flipping comma.
That's what it is. Yeah, that's. I didn't get it either. I think. Whatever. You got it. And we're on the last one, so we want to do this in milligrams per kilogram. So when they give us a drug dose, the recommended drug dose for this person, this kid, is 75 to 150 milligrams per kilogram. We're doing milligrams of drug, 2 kilograms of body weight. So we know a doctor prescribes 200 milligrams every 8 hours. I'm going to simplify things for you a bit because I'm getting tired and lazy, and it's getting near the end of the day, and I want to know y'all are getting the same way. He's giving them 600 milligrams of the medicine, right? So 200 milligrams, 8 hours a day, 600 milligrams throughout the day. The other thing is it's a 20-pound child. This is milligrams. I want milligrams per kilogram. What do I have to convert this thing to?
Kilograms?
Exactly. So I'm converting this to kilograms. And then I'm taking milligrams, I'm dividing by kilograms, whatever I get here. So my conversion factors are up in here. Oh, that's readable. I'd probably use this one, preferable to this one. So we are almost done. This is the last one. We just got to convert. 20. Okay, where are we at? How to convert 20 pounds to kilograms. I think I'm dividing it by this number, right? I'm either dividing it by 2.205 or I'm multiplying it by the 0.45. It should get smaller. It should get like 9.07. So 600 divided by 9.07. I think it's giving me, what, 66.15? So I should be getting 66.15 milligrams per kilogram of body weight. All right, and if he's prescribing 66.15, okay. I guess I got it broken down here. How much med? 3 doses of 200 is going to give us the 600 total. The 20-pound child, this was what I was talking about. You're either dividing by the 2.205 or multiplying by the 0.49. We divide those two numbers, we should get 66.15. So then the question is that good? Is that bad? Is that less than? Is it too hot, too cold, or just the right amount? And I'll give y'all 10 seconds because this is it. 66.15 is what he's prescribing. Okay, that's the last thing. I guess I got 7 people still awake. 66.15 is below the recommended dose that they were talking about. All right, so that is it for this section. If you got questions, I'm here.
Thank you.
All right, take care.
Bye.
Yeah, take care.
Thank you.
Thank you.
I can stop recording.